All right, we're going to start on page 381. Today and tomorrow we're going to spend all of our time talking about and developing the unit circle. And we introduced the unit circle before break. We said how a unit circle is simply a circle with a radius of 1. So we'll go ahead and jot that idea down again. So circle with radius of 1 unit. And we utilize this unit circle to help us understand or comprehend the idea of a radian, how we have this other way of measuring an angle. So just as a reference again, a radian, if you were to be standing on the unit circle, probably starting at this right-handed spot, okay, like on that initial side of an angle, a radian is just representing how far you'd have to walk around the circumference of the unit circle until you get to some spot. So that this is representing a radian amount, but notice how that radian amount is directly related to the angle that you would form. Okay, so we talked about that before break. We're going to come back to this unit circle and we're going to take a look at some different properties or labels on this unit circle that are very, very important in terms of trig functions. And I think I mentioned before break how if you don't learn anything else the rest of the school year, I want you to learn the unit circle. Okay, that's how important this is. So we're going to just first talk about the different labels or parts of the unit circle. We're going to work in degrees, which we're familiar with. And then we're going to work in radians, which we're starting to get familiar with. And then we're going to start looking at some ordered pairs. But I don't want to give too much away before we get there. Let's just first kind of start with the easy stuff first, those degree measurements. On the blanks, oh sorry, you can't see it. On the blanks on the inside of the circle, write the degree measure for theta, okay, some angle measurement, that would terminate at each notch. So let's just first start with this first blank on the inside. We always draw in the initial side first, okay, on the right-hand side of that positive x-axis. Can you check and see if someone's there? Good morning. Anything for the office today? I think we're good. Okay. Thank you. All right, so here's the initial side of our angle. What if we did not rotate any angle measurement? What would be the measure of our angle? Can you think about it? If you start and end in the same spot, you don't move at all? What was the angle? Yeah, 0. All right, so on this right-hand side, we're going to denote an angle of 0. Basically, the initial side. Doesn't initial mean kind of mean a value of 0, a starting amount? Okay, so this first dot, we're going to say on the right-hand side has a 0 angle measurement. The next tick mark or notch, or you can put a dot there if you wanted to, what if we were to draw in an angle that would land right there? Remember, this is our initial side, this is where we're starting. What if we were to draw in something right there? We want to figure out what that angle measurement is. And it might be difficult to notice, okay, just based with how this is measured, but let's see if we can go on to one that's a little bit more obvious. What if we wanted to figure out this angle measurement? Yeah? How'd you know it was 45? Good. Halfway between 0 and 90. So that must mean this angle all the way perpendicular would be 90 degrees. I like it. So notice how 45 is halfway through that quadrant. All right, so this is going to help us maybe figure out these other two. Go ahead and take a look at how these angles are related to each other. I'll put them in bold or solid lines. If a whole quadrant is 90, can you see it? Do you see it, Marie?
The one in between 0.5 and 30.
It would be 30. How'd you know it was 30?
Because it's having 2/3 on.
Okay, well, we're counting by thirds. We have a 30-degree angle, another 30-degree angle, and then another 30-degree angle. And altogether, 30, 30, 30 would give us that whole quadrant of 90. So that means this one up here, if we went another 30 degrees, would be 60. Okay, we're going to work our way around this unit circle. So what if we were to move into the next quadrant? Remember that the initial side is always on that positive right axis. What if we were to go to this notch or dot? Or maybe you can figure out the next one, or the next one, or the one directly to the left. Can we start to fill in some of those degree measurements? Go to Rebecca.
The one also the line with the 0 would be
180, good. Remember, each quadrant's 90 degrees, so if we go 2 full quadrants, that'd be 109 or 180. Can we fill in any of the other 3? Yeah?
the one at the top be 120.
120, how'd you get 120? That's good.
Because if you add another 30 on
If
it.
you add another 30, yep, 90 plus 30 would give you 120. Can we keep going? Good, Marie? 135, perfect. You want to do the last one? Yeah. 150. Perfect. All right, let's keep working our way around. Let's see, if we go another 30 degrees from 180, that would be 210. The next one, though, is a 45 degree multiple, so we'd have to take 180 plus 45 to get there. Then that would be 225. The next one, we'd have to add another 30 to the 110, so that would be 240. And then if we add another 30 to that, we'll have 270. Working our way all the way around. If we keep going, another 30 would be 300. Another 30 after that would be 330. Okay, but we're going to skip that middle block. And then what if we get back all the way to where we started? 360, right? Another 30 would be 360, and notice how that makes sense because there's 360 degrees in a full circle. What about the missing one we didn't fill in just yet? Yeah. 315, perfect. So you'd have to take 45 plus the 270 to get to that 315. Okay, perfect. Those are degree measurements. Do you think we can fill in the unit circle with degrees all the way through? We're just counting our way. All right, so now we're going to kind of switch gears and we're going to see what these degree measurements would look like in radians, because we know we have that other way of measuring angles. So before we do that though, we're going to use these degree measurements to help us out. We could convert every single degree measurement, okay, using our conversion factor, that 180 in pi amount, but do we feel like converting every single number? That would probably take us some time. So what we're going to try to do is look for a pattern. And I'm going to help you just kind of look at that or discover it fairly quickly. Maybe it's not too bad for us to notice. If you look at all of these degree measurements, okay, really closely, they are all either a multiple of 30 or 45. Do you see how 60 is a multiple of 30? 90 is a multiple of both 45 and 30. If you take a look at 150, that's a multiple of 30. Okay, so really, we're going to pay close attention to these 2 degree measurements and just convert those to radians. And then we'll use those conversions to help us fill in the rest of the circle. Okay, so the whole unit circle is either a multiple of 30 or 45, depending on which angle you want to use. Let's go ahead and convert both of those to radians. So can we think about, if we're starting with a degree and we want to convert it to a radian, what conversion we would have to multiply by? Our times in a line? Yeah. Pi over 180. All right. So what is 45 degrees the same as in radians? Or what is 30 degrees the same as in radians? Did you get it, Emily? Go ahead.
Pi over 4.
Good. Okay. Did you get the other one? Yeah.
Then pi over 6.
Pi over 6. Perfect. All right, so we're going to use these 2 radians to help us fill in the whole unit circle. For every degree measurement, we're going to convert it to a radian just by utilizing these 2. Now, we are going to have to be a little bit familiar with fraction work, because notice how these are fractions, but it's not going to be too complicated. We're just going to keep adding a fraction every single time. So on the outside little lines there, we're going to go ahead and write in the equivalent or congruent radian measures. So we first started off with an angle of 0 degrees. For radians, that would be 0 as well, okay, because you're not really moving at all around the circumference of the unit circle. If we wanted to travel an angle of 30 degrees, the equivalent radian would be if we were to walk, okay, this arc along the unit circle right there. So if we were to walk that arc, we would have walked a distance of pi over 6. Okay, now let's try to fill in some other values here. We said that every single degree measurement is either a multiple of 30 or 45. Let's go ahead and try to fill in all of the other multiples of 30 because we know what that radian value is. If we add 30 to 30, that would bring us to 60. What if we add another pi over 6 to this pi over 6? Instead of doing 30 plus 30, we can do pi over 6 plus pi over 6 because we know those are equivalent. 30 degrees and pi over 6 are the same. Can we think about if we were to add pi over 6 plus pi over 6, what we would get for the 60 degree mark? Can we do that fraction addition in our head? Are we thinking 2 pi over 6? Right? Can we simplify that fraction though? Yeah? Pi over 3. Good. So there's the equivalent radian measure for 60 degrees. Instead of having to convert or multiplying pi over 180. Okay, we're going to use the multiple relationship to our advantage. What if we were to add another 30 degrees to 60? That would bring us to 90. Yeah. There we go. So instead of having 2 pi over 6, if we add another pi over 6, that would make it 3 pi over 6. But if we simplify that fraction, we'll get pi over 2. There's the equivalent radian amount. If we add another 30 degrees to 90, we're going to get to 120. If we add another pi over 6 to 3 pi over 6, we'll get 4 pi over 6. But we can simplify that. 4 over 6 becomes 2 over 3. There's the equivalent radian amount. You see how we're just adding all the way across or all the way around? If we add another 30 degrees, we'll be at 150. If we add another pi over 6, we'll get 5 pi over 6. Can we simplify that? No, so that one will just stay how it is. If we add another 30 degrees, we'll be at 180. So if we add another pi over 6, that would be 6 pi over 6, but 6 over 6 simplifies to just 1. Okay, so there, notice how we have that correct relationship. Don't we already know that 180 degrees is the same as 1 pi? Isn't that our conversion factor? Right? So far, so good. All right, let's keep going. If we were to add another 30, we'd be at 210 degrees, but another pi over 6 would be 7 pi over 6, and we cannot simplify that. Another 30 will be at 240, so that would bring us to 8 pi over 6. But we can simplify that to 4 pi over 3. Another 30 would bring us to 270. So we'd be at 9 pi over 6. Simplify that, we'll have 3 pi over 2. Another 30, we're at 315. So we'd be at 10 pi over 6. Simplify to 5 pi over 3. And then another 30, we're at 360, yeah.
Wait. Oh, okay. I thought we would do it 350.
Oh wait, I wrote that in the wrong one. Right, we'd be here, right? 10 pi over 3, so that would be, sorry, 10 pi over 6, so that'd be 5 pi over 3. I wrote it in the wrong spot. Good catch. All right, another 30 would be at 330. So that'd be 11 pi over 6. And we can't simplify that. And another 30 will be at 360. So that would bring us to 12 pi over 6. But that can simplify to 2 pi. Didn't we say 2 pi was the circumference of the unit circle all the way around? Okay, so instead of taking the time to convert every single one of them, notice how we're simply using that multiple idea to just count our way around. Do we see that? We're going to repeat the process. Okay, this time we're going to go ahead and try the 45-degree multiples. So let's start with our 45-degree angle. We said that was pi over 4. If we add another 45 degrees, we're going to be at 90. But if we add another pi over 4, that would be 2 pi over 4. Isn't that still the same as pi over 2 if we were to simplify it? Okay, so that one's kind of already filled out for us. If we do another 45, we'll be at 135. So another pi over 4 would bring us to 3 pi over 4. Another 45 degrees, we would be at 180, and another pi over 4 would bring us to 4 pi over 4, but isn't that the same as pi? Okay, so it's checking out so far. Another 45 degrees, we'd be at 225, and another pi over 4 would bring us to 5 pi over 4. Another 45 would bring us to 270, so that would be 6 pi over 4, but isn't that the same as 3 pi over 2? Another 45, we're at 315, so another pi over 4 would be 7 pi over 4. And another 45 degrees would be at 360, so that would be 8 pi over 4, but isn't that the same as 2 pi? So it all checks out. So if you would prefer to convert all those degrees to radians, I'm not going to say that you can't. I'm just going to tell you it's going to take some time. But what we can do is maybe ease that process a little bit by using the multiple ideas with the 45 and the 30 degrees. Okay, we can just count our way through. All right, so this is what the unit circle would look like if we were to label every degree measurement and every radian measurement. I know that there are other degree measurements. We could draw in an angle of 15 degrees. We could draw in an angle of 70 degrees. But the reason that we're focusing on 30, 45, 60, and 90 is related back to those two special right triangles that we talked about in the very first section. Remember, we had the 45, 45, 90 triangle and the 30, 60, 90 triangle. Those are the two special right triangles. So those are the special angle measurements that we're going to pay attention to in the unit circle. Okay, we're going to keep adding to this. I know it's kind of busy right now on the front page, but we're going to start to write some other pieces of information on the unit circle as well. Okay, so what we're going to do is on the blanks on the inside of this next unit circle, we're going to write the radian measure. So we already did that on the front. You may have to flip back and forth, but now on the insides, I want you to write the radian values. On the previous one, those were the degrees. So we started with 0. We said the first tick mark was 30 degrees, but that was equivalent to pi over 6. And the middle tick mark was 45 degrees, but we said that was equivalent to pi over 4. And then we counted our way through all of the other ones. So if you want to practice counting your way through, you can. Or if you want to flip back and forth to copy, you can do that as well. Okay, but we're going to go ahead and fill in all the other radian values. All right, the next thing we're going to check out, or another characteristic of this unit circle that we're going to identify, are trying to figure out the coordinates of the points. Like on those little notches, if you were to draw in a little circle, what would the coordinate, aka x and y value, be of those particular points? So just like we have a regular graph, we have the x-axis and the y-axis. We're going to try to figure out what is the ordered pair of each one of these points. Now remember, this is the unit circle, so we have a radius of 1 unit. We're going to go ahead and use that to our advantage as we work our way through. So let's think about this kind of first beginning point on the right hand side, just like the initial side of an angle starts right there. What would the ordered pair of this point look like if we were on a regular graph? Yeah. 1 comma 0, right? The x value would be 1 because you go to the right 1 unit, and the y value would be 0 because you don't go up or down at all. Now what is going to get a little tricky is if we were to take a look at the next point, okay, the radius is still 1, but notice how the x distance is different. If I were to draw in a vertical line right there, clearly this x distance is not the same as the 1 distance all the way to the right of the unit circle. Very similarly, if I were to go to the middle point, notice how this x distance is not the same as 1. So it's not going to be a value of 1 for the x coordinate all the way around. Let's go ahead and try some of the easier ones, like the very top and the very left and the very bottom. What would the coordinate of the very top point be? Good, Marie? 0, 1. How about the very left point? Yeah? Negative 1, 0, good. And then the very bottom? You want to end it? Yeah. 0, negative 1. Okay? Those are kind of the easy ones because those are the ones where you go out the complete radius, aka to the end of the circle. So all the other ones are going to be a little tricky. But we're going to utilize trig to help us figure out those ordered pairs. And to do that, do you guys realize how I drew in a right triangle? Do we see that? We're going to go ahead and use that right triangle to our advantage. Okay, so in the bottom part below, we're going to just draw a rough sketch of what we're trying to find, and then we'll utilize trig to help us out. So let's say, I don't really know which point this is going to be, but let's say we were trying to figure out that particular coordinate on our unit circle. We'll go ahead and draw in a right triangle to help us out. Notice how the hypotenuse is that radius of 1 because you're going from the middle of your unit circle out to the edge. The legs of the triangle, though, are representing the x and the y that we're trying to calculate. Okay, what's the x distance left or right, and what's the y distance up or down? We also should be able to use the angle that we create with the center of that circle. All right, so let's say for our first case here that we wanted to let the angle be 30 degrees. Okay, so on our unit circle, we're going to try to figure out what this coordinate is for the 30-degree mark or the pi over 6 mark. Remember, those are the same thing, 30 degrees, pi over 6. If this angle is pi over 6, let's go ahead and set up a trig relationship using x or y that we could possibly use to help us figure out either x or y. Which do you want to figure out first? Do you want to figure out x or do you want to figure out y? Let's just start with making some decisions. Do we have a preference? Let's try x, okay? Which trig function can we use in this right triangle that would utilize the x that we're trying to figure out and the value of 1 that we already know? Yes? Cosine, right, because this is the angle we're using, okay? So we'll say cosine of 30, and can we write what that relationship would look like? Would it be x over 1 or 1 over x? Yeah? X over 1, good. All right, so on our calculator, make sure you're in degree mode. Go ahead and type in cosine of 30. Do we get 0.866, something like that? Okay. So cosine of 30 is 0.866, and x over 1 is just x. All right, now that's nice to know. We know the x-coordinate is 0.866, but there are some other decimals after that. What we're going to try to do is be very, very accurate. We want to get an exact answer. So if you were on your calculator to try to turn this decimal into a fraction, would your calculator be able to do that? Go ahead and try it. Do that math frac option. Yeah. It wouldn't. Okay, so that means this decimal that we have is irrational. There's no way for us to represent it as a fraction exactly. So it has some type of strange number in it, like pi or maybe a square root, something that's not considered a rational value. So this is nice to know, but we are not going to write this decimal down for the x-coordinate. We'll come back to this in a second. Okay? Let's go ahead and try to figure out what y is. So instead of using cosine, we can utilize sine. Sine of 30 would be y over 1. So again, on our calculator, let's type in sine of 30. What'd you get? Yeah? 0.5. Do we know what 0.5 is exactly as a fraction? Yeah. 1/2. Okay, so that's what we're going to use. So on our coordinate, on our unit circle, we're going to let the y value be 1/2. All right. Now, we have an idea about what the x-coordinate should be, but we want to write it as a fraction, not as a decimal. Let's see if we can approach this from a different angle or a different method. We now know that the hypotenuse is 1 and the y value is 1/2. Is there another way we can figure out what the x distance is instead of using trig? If you know two sides of a right triangle, yeah? Let's try the Pythagorean theorem. Okay, so in our Pythagorean theorem, we would have x squared plus 1/2 squared, and that would equal 1 squared. We still should be able to solve for x, but maybe we'll get a fraction this time instead of a decimal like we did on our calculator. So let's see. 1/2 squared would be 1/4, and 1 squared is 1. If we subtract 1/4, we'll get 3/4. And then if we square root both sides, we would have the square root of 3 on top. And then what about the square root of 4? That would just be 2. Do me a favor, on your calculator, type in the square root of 3 divided by 2. Yeah?
You would still get the same answer.
You would still get that 0.866 answer. Okay? So 0.866, your calculator could not turn it into a fraction for you, but notice how we were able to do that by hand. Okay? So in our coordinate for the 30-degree point, because that was the angle we were using, the x-coordinate was the square root of 3 over 2, and the y-coordinate was 1/2. Okay, we're going to repeat the process for the 45-degree angle and the 60-degree angle. And I don't know about you, but I don't feel like going through all the other ones to repeat the process. But maybe we can utilize a pattern after a while, like we did for the radian values. Okay, so we're going to stop there for today, but tomorrow we're going to pick up with the same kind of mathematical analysis. We're just going to go ahead and try maybe the 60-degree one next, and then the 45. Okay, so in the end, our unit circle, we should know every single degree value, we should know every single radian value, and we should know every single ordered pair value in the end. Okay, and then we're going to practice analyzing it and using it to help us answer some trig questions. All right, so like I said, we'll stop there for today.
1.